I have this Notion database that I use to keep track of my published videos. The reason I decided to do this project was because I followed Thomas Frank's tutorial on using make.com, but because of their free tier and the limited number of operations, you could only update your database about once a week if you didn't want to spend more money. And we're going to do this completely free. We'll just have to write some code. Before we get to the code writing part though, we need to retrieve what's called API keys for Notion and YouTube. These API keys serve basically as a passcode to allow us to retrieve data from these services. But what exactly is an API? It stands for Application Programming Interface. You can think of it as a set of rules of how computer programs talk to each other. Imagine it's like a business contract written in English specifying the information that needs to be exchanged. Just as you can't ask for anything outside of what's agreed in the contract, you cannot request the information that the API doesn't provide. Essentially, APIs are bridges between the software programs that allow them to communicate with each other. Our program will have to communicate with two APIs. That's YouTube API and Notion API. Let's start with getting the YouTube API key first so we can retrieve the data about our videos. So what we need to do is go to console.cloud.google.com, and then you may be presented with this screen to select a project or create a project. And if you don't see anything like that, then you can just click here and click new project, and we're gonna call it YouTube to Notion. And you can leave organization as no organization because just gonna be you probably, and click create. And it's gonna take a few seconds to create your project, and then you'll get a notification that the project was created. Just click select project. Here, as you can see, we are already on the screen. Now we need to go to APIs and services because we need to enable access to the YouTube API for our application. So it looks like maybe it enabled a bunch of them for some reason. But if you don't see that, you click enable APIs and services, and then you search for YouTube. And what we're after is YouTube Data API version 3, and click enable. Okay, so now we have access to YouTube API. What we need to do now is set up credentials. We will go to the Credentials tab and click Create Credentials and click API key. What it's going to do is basically just give you your API key, which is like the passcode that will allow you to retrieve data from YouTube. So copy that, make sure you don't share it. I'm not gonna implore it or anything, I'll just delete it after I record this video, but make sure to keep it safe. Now we close this, just make sure to paste it somewhere where you can find it later, and that's it. We got the YouTube API key. First thing we wanna do is restrict it. Click on these three dots, click Edit API key, and then right now in API restrictions, it says don't restrict. So you can use this API key to call any of the available APIs, but we want to restrict it to just YouTube. And click OK and click Save. Now we got the API key. So now let's set up our project. I'll open VSCode and then we'll just create a new folder somewhere. I'll just do it here in Documents. So we'll call it YouTube to Notion. Yes, we want to trust the authors because it's my personal computer. So now we're gonna create a folder and we're gonna name it Lambda because we're gonna deploy this code to AWS Lambda, so might as well. And then whenever you create a Lambda, your file should be called, I believe, lambda handler.py. We're gonna do that in Python, but feel free to use any other language. Okay, I've already pre-written this code to save us time. First, we're gonna import the requests module from Python, and you may not have it, but I'll show you how to fix it if you don't have it installed. Obviously, first need to have Python installed, so I'll take care of that first. But then we got the base YouTube URL. That's the base URL for the YouTube API. Then we specify the YouTube API key. And here is a simple method called getVideoDetails. It takes in a list of video IDs. And the reason for that is so we can get information about multiple videos as one quota. Projects that enable YouTube Data API have a default quota allocation of 10,000 units per day. If we are to retrieve each video individually, it would be 1 unit per each video. But if we're doing this, where we send the whole list of IDs, YouTube limits it to 50 IDs per request, but it's still, we're getting information about 50 videos as a single unit. That's why we have this logic to basically split video IDs in chunks, if in case you have more than 50 videos in your Notion database. Then for each chunk, not for each ID, but for each chunk, we're gonna join the IDs, create the URL with the API key and the list of these IDs, get the response, and then basically map the response to the format we desire, and then return it. I just got one ID from the Notion database. Before we print this, let's just run this and see what kind of response we get from YouTube API. So we run this, it says no module named requests, so that's easily fixable by pip3 install requests. If pip3 doesn't work, just try pip install requests. Now, if you run this again, it still says no module name requests, but that could be because you have the wrong interpreter selected. So what you will do is click right here at the bottom right and change it to this one. We got the request problem fixed, but nothing happened because we didn't call this method. What we're gonna do is just call it, and that's the response we get from YouTube API. Obviously, this is just for one video because we only sent one ID. And what we can do is Google JSON viewer and then paste it here and then click viewer. And this will let us view it in a more structured way. We go to items, 0, and then in the snippet, you can get the information about the title, description. You can even get the URL to get the thumbnail. And then what we care about really is the statistics, view count, like count, comment count. So we got the YouTube data. The next thing we need to do is get the Notion API key. So we could retrieve data from the database and then also update each row once we retrieve the data from YouTube. You will basically go to notion.so/myintegrations. And I've already created an integration before, but let's just create a new one. Let's just say YouTube to Notion. You don't really have to care about logo or anything. And here it's going to give you the integration secret. And then you click show, click copy, save it somewhere where you can access it. And here in capabilities, we don't need to mess with it. But if you wanted to restrict it to, for example, have a different API key for reading and updating content, then you can do that. You'll just change the capabilities. We're not gonna worry about it for now. Now let's test this Notion API key. Gonna go back to VSCode. Now we can say Notion API key equals, then we also want the base Notion URL. And now again, I've pre-written this method. So it looks like we also need the what's called a Notion DB ID. And in order to get that, we go back to the browser, we go to our project, and it should be this part after so/, so right before the question mark. So we do Notion DB ID equals this, and now we can comment this out for now. And now we just query Notion database. And let's see if this works. It says it cannot find database with ID that we provided. Could be for one of two reasons. Either this ID is not the ID, maybe we retrieved it wrong, but actually we also need to allow this database to be shared with this API key. So in order for us to let this API key connect to this database, we click these 3 dots, click connect to, and then we search for the name of the connection we created. So it should be something like YouTube to Notion. It will say YouTube to Notion will have access to this in all child pages, and we confirm. Then we go back to VS Code, and nothing got printed, but because we did not print anything. So if we actually print this, then we will receive this response, and it's gonna be quite big. So we can copy it and go to JSON viewer again. Okay, it says invalid JSON format for some reason. The reason you may be getting this invalid JSON variable error whenever you're trying to preview the JSON is because whenever we print response JSON from here, we are printing the Python dictionary object, which is technically not JSON. Looks like JSON, but it is not. Instead, we just need to print JSON dumps response JSON. So now when we save and run this, we can now copy this, and you see one of the changes that have been made is now we've replaced the single quotes for each key value pairs with double quotes. None has changed to null. And then things like true and false went from being capitalized to being all lowercase. And whenever we paste this now, we should have this structure. And now you can take a look and see what the properties you need. Here in this response, we got 100 objects in our results. Even though you see 99 here, we start counting from 0. For each object's property, we are able to retrieve further properties to know which values we need to update. For example, here, the likes, it tells us the type, that it's a number. So it expects us to pass in a number instead of a string, for example. What we're interested in right now, though, are the properties of YouTube ID and the page ID, because that's how we are going to map YouTube IDs to page IDs. So in order for us to get those, we would go through the results object, iterate through each item in this list, get the YouTube ID, and then formula, and then string, and that's the ID. And then here, each object in the list has an object type and the ID. And that's how we will know which page, which is basically a Notion database row, we will need to update. That way, whenever we get the data from YouTube API, we can easily map it to page ID and update the correct page right away. Here is the simple code that will do that. For each page in the response results, we get the page ID, get the YouTube ID, and then we save it all into a map, and then we return this map. If we just print this instead, let's clear this to make it easier. Now, as you can see, we have a map where YouTube ID is the key and page ID is the value. We got almost all of the code written. Obviously, the most important part is the updating part. Unlike how we did with YouTube, where we could just retrieve 50 video IDs at once, Notion unfortunately doesn't allow you to update multiple rows at once. So we still have to send a separate request to update each individual row. I already have some code that does that. First of all, we need to import the JSON module. It should already be a part of the Python library, so you don't need to worry about installing it. So let's see what this code does. Here we have the URL where it's base URL /pages/page ID, and then pass in the headers, which is basically the authentication information, and then we send the data that we want to update. The way updates work typically, but specifically in our example with Notion, it will only override things that we provide, and it will ignore things that we don't provide. If we go back to my database, we're going to be updating views, likes, comments, and title, but it's not going to update anything else. We can just remove all of it, actually. And we could probably just remove all the titles too, just to make sure it works. Now, what we're going to do is insert another piece of code here. And we're going to call it Lambda handler. That's because we will need it to be named exactly that later. But here's what it does. It gets the IDs, gets the map of IDs, YouTube IDs to Notion IDs. Then we also get the video details. And then for each detail in YouTube details, we send the request to update it. Here we can just call Lambda handler. Event and context, they will get provided automatically whenever AWS Lambda invokes this function, but we're not going to be using them. So we can just put none and none for now, or just not put anything. We can clear this, and it's going to take a few seconds. It looks like our method finished executing. So now we go back and see that everything got populated again, and I did not touch a single thing here. The next thing we want to do is being able to have this code run automatically, a certain interval schedule. And what are our options? There are a few, but I would just go with AWS Lambda, because mostly talk about AWS, and it's quite simple to set up. It's going to cost you nothing unless you do like more than 1 million requests a month, which is probably very unlikely. We can just go ahead and do that. So we have two ways of creating AWS Lambda. You can either go to aws.amazon.com, log into console, and manually create everything. In software companies, especially like big software companies where you have multiple developers on the project, it is a good idea to have your what's called infrastructure, like all of these things in the cloud, be defined in code as well. That way you can keep track of who changed what when, instead of if somebody like goes and updates something in the UI and something breaks and you have no record of it happening, or you have to, play Sherlock Holmes trying to figure out who did what, when, and why, and that person may not even be working there anymore. That's why it's a good idea to have infrastructure as code as a part of your process. We're going to do just that. We are going to create a new folder, and it's going to be called CDK. And in order for CDK to work, regardless of which language you choose to write your infrastructure code in, you still have to have Node.js installed. You can test if you do have it installed by running npm version, and it should tell you the version. If it tells you like command not found or something, then just go to Node.js and basically just download it. After we installed Node, what we want to do is do npm install -g AWS CDK. And it looks like we are running into permission issues. And obviously you don't have to actually install it globally. You can install it as, let's see if I remember, dev only. We install it locally, and now you can see that this huge node modules folder was created. Now we can also Google how to do AWS CDK in Python. We can just follow these instructions, make sure that all of this, you can just copy this and paste it in here, and it says command not found for some reason. So Python 3. Okay, I guess you can just use Python 3. Just follow the instructions. It's gonna update things for us. So we already created a folder. So now what we want is CDK init language Python. Just make sure that you're careful where you do that. Here I am in just the root folder, YouTube to Notion. What we want is actually CD into CDK, because we're gonna have a Lambda project and CDK project. They're two independent projects, but we'll just have them in the same repo. You do CDK init app language Python. You should have a bunch of these folders under the CDK folder created for you. And what we're after is this CDK folder and this CDK stack. I'm just going to paste it and I'll explain what it does. Here we do a bunch of imports, and then inside the CDK stack class and inside the init method, what we want to do is define our Lambda function. Give it a name, give it the runtime. That's basically which language version we want to run it as. Then we give it the handler. So our handler is Lambda, Lambda function, Lambda handler. Actually, what we need to do is change this to Lambda function, otherwise it won't find it. Or we could just change this to Lambda handler. And then here's an interesting line. We're basically saying that we're going to upload the code from lambda package.zip, and I'll show you how we're gonna handle that in just a second. And then the timeout is 5 minutes. It's probably too much because our function should really complete in less than a minute, and your build more the longer your function runs and the higher memory it uses. But that should be fine, because if it doesn't run for more than a minute, we'll only get built for a minute anyways. And here we give it the memory size. The default of 128 might be enough, but just to be a little safer, do 256. And then I'm gonna skip this part for now. I'll explain it in just a sec. Then we go to rule. Rule is where we define the interval at which we want to have this Lambda function run. And the way it basically works is AWS will create an event and send it to AWS Lambda function at this specified interval. And then we just set this Lambda function to this rule. Everything would be just perfect. Let me comment this out and we can see if we can deploy it right now. And the reason I'm commenting this out for now is we will store our secrets in a more safe manner rather than just hard coding them right here. But just to test to see if it works, let's try to zip this function and deploy it. The reason we need the zip file is because AWS Lambda won't install the requirements by itself. Basically, we need to package all of them. So here we use the requests module. It's not going to have access to it unless we package it in a zip file along with our Lambda function. So the best way to do that is actually create a virtual environment for our Lambda function in which we will install everything, and then we can package that virtual environment into a zip file and give it to Lambda. But because of how difficult it is to remember all the commands you need to run, and you may just mistype something, forget that something needs to happen, that's why it's best to also write code to run all of these commands just whenever you need them. One tool that developers typically use is called Makefile. And again, I'm just going to paste the code and explain what's going on. Here we're defining some variables like directory names, virtual environment names, etc. And then here, the default target. Makefile has a bunch of different targets. So the target name is this string before the colon. And here it just says, hey, if you just type make in the terminal, I'm going to do these steps. So it's going to do package. Well, package relies on dependencies. Dependencies relies on VNV. So it's going to do VNV, dependencies, package. And it's going to do CDK VNV. And then it's going to do CDK bootstrap and CDK deploy. And then in the end, it's just going to clean everything. Actually, should clean everything here. Currently, we just want to see if zipping will work. So what we can do is just type make package. And here we can watch it installing things. And the reason it failed is because we do need a requirements.txt file. That's how it will know what dependencies we actually need to install. So we paste requests and the version. You can just go to PyPy and see the latest version. Currently it's 2.31.0. So now we just make package again, and looks like we got our zip. So now if we created the Lambda function manually, we could just go to the UI and upload it, but we didn't. So now we again have the options of manually running a bunch of commands to do the CDK stuff, or we already have it defined in the Makefile. So there are two commands you need to know. It's CDK bootstrap. It only really need to be run once, but running it again just won't do anything. So it's not bad to have it there. And what it does is creates different resources in your AWS account that CDK requires. Typically, it's some S3 buckets where it basically keeps track of where things need to be stored, probably like creates a CloudFormation template, and then CDK deploy actually deploys your application. Now, we could either just run make CDK bootstrap and make CDK deploy, or we can just run make and it should work. It's probably not going to work for you though, because you don't have AWS CLI configured. Let's take care of that first. We'll just Google AWS CLI configure or install, and then choose your operating system. Now you can either download the package or just use the command line and just follow these steps. And then after you have it installed, you should have this, well, it should tell you which AWS or AWS version. Either of these commands should give you some type of output. And then you want to actually configure your AWS CLI. And you want it configured because by default, your computer doesn't know you even have an AWS account. So there are multiple ways to configure it. What I usually do is I just go, let's clear it again. I just do AWS configure, and it asks you, hey, what's your access key ID? That's where you go to your aws.amazon.com, log into your account, and then you go to IAM. And if you don't see it in here, just search for it like over here. And what you want is users. You don't want to use the default root user credentials. You want to create a user with admin privileges. And so I guess I'll just do that. We don't need to provide user access to AWS Management Console because we will only use it in code. We can just attach policies directly. So we just give it administrator access, click next, then create user. And now we click on admin and go to security credentials. And then we scroll down and create an access key. So we can either choose one or two and then say we understand that there are better options, but that's fine. And now we basically copy this access key, go back, paste it in here. I'm not going to change it, but obviously you'll insert whatever was given to you. And then obviously you can just copy this. And then again, you do this. And then you choose the region name. Depending on where you are, it really doesn't matter much. So if you're in the East Coast, you can just do US-East2, or if you're in Europe, there are other region names, but we're just gonna stick with US West 2. Default output format is JSON, and we're done with AWS CLI configuration. So now, if you run make, it should create a new Lambda function for us. Hopefully we didn't forget anything. Okay. So it's installing a bunch of things. What it does is basically it creates virtual environments for both CDK and Lambda, installs all the dependencies that are needed first for CDK to like deploy things, but also, as we already talked about, for Lambda to actually be able to run. And then it runs obviously the zip command, and then it runs CDK bootstrap and CDK deploy. And that's what it's basically doing right now. What it's doing for me is updating my existing AWS Lambda function. And that is because I gave it the same name as I was already testing it previously, this update Notion DB. When you run it the first time, assuming you don't have the same Lambda function with the same name, it should create one for you. If we go back to our AWS account, go to Lambda, and it would be named something like this, CDK stack, and then our name we provided, and then some random letters and numbers. And here it basically says that it's too large to enable code editing, but we can invoke it. So you can click test and basically just watch it execute. It's not gonna really print anything. It may give you an error if we forgot to configure something. Otherwise, assuming it's already been running for 15 seconds, it's a good sign. That means it's just updating our database rows. This taking longer than has taken previously. Well, it actually did print something because I forgot to remove the line to not print this. Assuming it's green and it says succeeded, your AWS Lambda was successfully deployed via CDK, and it runs the code that you provided. So we can confirm in configuration that you have the trigger and has enabled the rule state, and the schedule expression is once every hour. And this every hour, once an hour, and typically it's around the time when your function was created. So if it was created, let's see, 10:52 a.m., then the next execution is probably going to be around 11:52 a.m. And we can actually look at the monitor because it's been running for a while for me and see the recent invocation, 15:37, 16:37, 17:37. You can look at the log stream and it just succeeded. This is all good, but remember, we still have hard-coded API keys in our code, and we definitely don't want to commit it to GitHub or anything like that. So what are our options? The one I discovered, that's the free one. Let's see, Parameter Store. Here, I've already created these keys before, or these parameters. But let me show you how you need to do that. As you can see, they all have the same prefix. We want the same prefix, so in our CDK code, for example, we could just use the prefix, then slash, and the star for the wildcard, so we don't have to manually specify each key if you decide to add more of them for some reason. The way you create these is you create parameter, and then you can just say another API key. So we give it the same prefix, give it the name, and optional description, so you remember what it's for. The standard is fine because we're not going to do anything fancy. And then here as the type, you want to use the secure string. Honestly, I just left the KMS as default. Feel free to create your own KMS and use that, but this works just fine. And then here you will paste your API key, and then you just click create parameter and it shows up on here. So now we need to update our code to retrieve these. I'm gonna delete this since I already have the ones created, but basically you do this for your Notion API key, Notion DB ID, and YouTube API key. I guess you don't necessarily have to do it for Notion DB ID and can just hard code it. So now back to the code. Here we're going to replace all of these secrets with the call to the store manager. So what we want is import Boto3, and we may need to install Boto3, but remember now that we actually don't need to install anything anymore once we run the make commands. So here we create the store manager client, then we define the function to get the parameter. We want it with decryption since we encrypted it using the KMS key, and then we just get the parameter value. And now instead of doing this, we just do this. So now if you try to deploy it, our AWS Lambda will actually fail because we didn't give it the permissions to decrypt the store parameters. So let's go back to our CDK stack, and here we're gonna uncomment this. So our actions are to get parameters, and get parameters by path, and we want to allow it. So effect is allow. We want to allow it for the resources with this prefix. And then, as I said, we can just use the wildcard. Oh, by the way, the way you get these resources, like what to put in the resources. So after you created your store, you basically just go to like one of these keys you created and just copy this ARN and then just paste it in code. After we've done that, if you run the make command, it should basically repackage the zip file since now we've changed the code. And then it should deploy it. Actually, it's gonna ask you, it's potentially sensitive changes. Do we really want to allow this AWS Lambda to do this? And yes, we do. We could have avoided all of this and just use environment variables in AWS Lambda. The problem with that is, especially when you're using CDK, is that if you don't hard code them, on the next deployment, they'll just get overridden with nothing. So we have to choose the lesser of the evils. And I think this is a good option, especially since like they have a stupid limit on the free number of requests. This should not cost you a single penny. Like whatever we're doing should be absolutely free. So now we're gonna see if it still works. Okay, so it did say it updated a minute ago. So now we just can go back to test, click test, and wait about 45 seconds probably again. And that's a good sign, it's working typically. Usually if some error happened, probably would have failed in the first 3 seconds. Maybe 5 seconds. It's taking longer than the last one. And that's probably because we were now making extra calls to retrieve the keys. So it succeeded. Let's just make sure that didn't wipe anything out. Now, what if I told you that actually there is something else we can automate? Instead of typing all of these commands that we've typed already, what if you just needed to type, let's say, 3 commands? How about that? Let me introduce you to Docker. And what Docker will allow us to do is create an environment that I can share with you. That it doesn't matter whether you're on the Mac, Windows, Linux, it will just work. Obviously, if you don't have Docker installed, you still need to do that. So you will just go Google Docker install and just install for whatever operating system. After you've done that, what we can do is create a Docker file. And let me explain what it will do. This is a simple Docker file to basically create our own image. We use the base image from Python 3.11. That's what we've been using. Then we basically update the operating system. Then remember I had you install Node. Well, you no longer need to do that. It will do it for you. Remember I had you install AWS CDK via npm. It's gonna do that for you. Then we just set up the working directory and copy the current contents into the container. And then the last command is basically to make sure the container just keeps running, because otherwise it will just like start and then immediately stop. So the next thing we want to do is create a Docker compose file. So here is a simple Docker compose file. And what we are after is the AWS access credentials. The reason we want that is so you don't have to go and configure AWS CLI or whatever. Obviously, you could do that and then you could just share credentials with the Docker container. But I think this is a much simpler approach, especially since you already have to like go and create those. Might as well just provide them to Docker here. We're going to read them from somewhere. The way it works is we're going to create this file called .env. And here you will just paste this and replace the key ID and access key and probably the region with whatever you have configured. Obviously, this is still in plain text, but if it's the computer you're not sharing with anybody, it should be fine. Just make sure that whenever you do git init, that you create .gitignore file and ignore env. That way, if you do upload this code to your GitHub repository and somehow accidentally publish it to a public repository, nobody's gonna steal your API credentials and like start mining Bitcoin on EC2 instances or something. So here we can now remove this node modules thing because we don't really need it anymore. The other things we want to include into gitignore is .venv, because we don't want to commit to get the whole virtual environment we created with like all the dependencies. So after we did that, look, our changes have become pretty small and more manageable. After you've done that, after you've set up your environment variables, I told you it's going to be just a few commands that you run. The first command you're going to run is going to be docker-compose app-build-d. So it's going to use our Docker file to build an image. You can actually see it in the logs. And then it's going to create a container with these environment variables that we specified here, well, really in our .env file. And then builds the container and then it detaches us, because if you don't do this -d, our terminal wouldn't let us do anything. It will just sit there forever. Now, the next thing we want to do is get into the container so we could run the commands in there. So we do docker-compose exec dev-environment bash, and it's gonna bring us to a bash shell. And we have the root user. It's fine here. Our container is isolated from everything, so we don't really care about that. And then the last command you run is make, and then you just wait. And it's basically going to do the same thing that it's done before in our local machine, but now it's going to do that in Docker. As you could see, instead of having to like go and run a bunch of commands in the terminal to set up CDK, to configure AWS CLI, whatever, we just run 3 commands and everything's done for us. Obviously, you still need to create the Notion API key. You need to still create the YouTube API key, and you still need to create the AWS API key. But other than that, outside of installing Docker, there is not much else you need to do. I'm going to commit this code to a GitHub repo, so you can just go and download it and try it on your machine and see if it works, and maybe you can make it better. And now, as you can see, it deployed things, and I'm not going to test it again because I know it works. And this is it. This is how you can create and deploy code that will update your YouTube stats in your Notion database at a given interval. And if you still have not subscribed to my newsletter, then now is the time to do that.